All right, this is just another segment in this long week of notes. This is the last thing we need to talk about. Graphing theta given parts. This is graphing but completely backwards. So this will take a bit of time to get used to. I do find these problems fun, but it takes several examples to really figure out what's going on here. So we're just going to do examples, and we'll do as many as we can. Find theta in degrees. We have tangent of theta equals 1 and sine of theta is greater than or equal to 0. And that's our givens. That's all we're told. So instead of being told directly what theta is, we're told clues about theta, and we'll use these clues to figure out what theta is. This on the surface looks like not that much information, but there's so much we can figure out from this. So let's start with the tangent theta. There's really three pieces of information we can take from this. Let's start by rewriting this as a fraction. If your number's 1, then that's the same thing as 1 over 1. How is that helpful? Yeah, let's back up a little bit. Yes, that's correct, but let's back up. We'll get there. Bless you. Before that. Okay, I'll add that to the list. That was going to be my next point. It's positive. Tangent is positive. One more thing, it's specifically with the fraction. Why did I create a fraction? What do those numbers represent?
The A and O.
Exactly. So this tells me O and A, and once we graph it, yes, we will see this is going to be a 45, 45, 90 triangle. The other piece of information, it comes from sine. There's only really one thing to get from this, and that's the sign on the sign, whether it's positive or negative. If it's greater than or equal to 0, that means sine is positive or it's 0 because we have that equal to case. If your O and A both are not 0, your sine will not be 0. That only happens on the quadrantals that we talked about last time. And reminder, quadrantals means one of these sides will be a 0. So they're both 1, sine's going to be positive. So since we know that tangent and sine are both positive, which quadrant are we in? Quadrant 1. So I'm going to make a list, and I'll only do this for the first problem, but just to compile all the information. So first off, we know O is 1 and A is 1. And we know we have positive tangent and positive sine. Therefore, we are in quadrant 1. That's the only time that happens, is in quadrant 1. Now we can draw a graph. And at this point, we still don't quite know what this angle is, but we know where it's at. We're in quadrant 1, angle of rotation. Theta equals, we're still trying to figure that out. So instead, we're going to start with the triangle. H is the hypotenuse, O is the vertical, and A is the adjacent, connected to the alpha that we're still going to determine. And then the sides we do have. We know that O is 1 and A is 1. Now we've already figured out that it's a 45, 45, 90. But I am going to write out both triangle options because this is what you should be thinking about as you go through the problem. 45, 45, 90, that's 1, 1 rad 2. And then 30, 60, 90, that's 1 rad 3, 2. And we have 1 and 1 for the two legs, so clearly our hypotenuse is going to have the rad 2. Based on that information, we now know that alpha is 45 degrees, because these are both going to be 45-degree angles. Lastly, we can now determine what theta is. What is theta? Theta is also 45. We're in quadrant 1, where alpha and theta are going to be exactly the same, so 45 degrees it is. So the overall question was to find theta in degrees, which we did, so we are done. Let's do another one. Example 2, we'll find theta, this time in radians. Our givens, sine of theta is equal to 1/2, and cosine of theta is less than or equal to 0. Now that you kind of see where this is going, hopefully your brain's already working on some pieces of information we can pull from this. Sine of theta is 1/2. That is extremely helpful information. We remember that sine is O over H, so it's handing us the values of H and O. We now know O is 1 and H is 2. And again, let's think about our options for the two triangles. It will be one of these two. 45, 45, 90, that's 1, 1 rad 2. And 30, 60, 90, that's 1 rad 3, 2. Which one do we have this time? 30, 60, 90. We have 1 and 2. That matches the 30, 60, 90 ratios. And specifically, the H gives it away. It's either going to be rad 2 or 2. It's 2 this time. So this is a 30, 60, 90 triangle here. One other piece of information. Cosine is less than or equal to 0. So we know cosine is negative, or it's 0. We've identified which triangle this is, so it's not a quadrantal. We know that. And one more thing, sine is positive. So if we have positive sine and negative cosine, we are in quadrant 2. Yes. Quadrant 2, it's the only time sine is positive, cosine is negative. All right, let's put this all together. So we know we're in the second quadrant. And don't forget, we're doing this in radians. That's the easiest detail to forget when you're getting into all this work. The question says in radians. So let me go ahead and label my axes in radians so I don't forget about that. This is 0/2 pi. This is pi. And we haven't determined what the denominator is yet. Maybe you have, but I haven't gotten there yet. So we're going to leave these like this for now. We're in quadrant 2. Let's draw that. Angle of rotation. Theta equals, we're still figuring that out. Alpha, x-axis, up to meet the angle. Let's go ahead and fill in the triangle. We know that information. H is the hypotenuse, O on the vertical, A on the horizontal. O is 1. H is 2. So that means A, our third side, must be the missing link, which is the square root of 3, since we know we have a 30, 60, 90 triangle. On this problem, it's not a huge deal if you don't notice it, but let's keep it in practice. Don't gloss over this small detail. This is a negative rad 3, since we're on the left side of the x-axis. All right, from here we will figure out alpha, and then we'll figure out theta. Alpha is how many degrees? Alpha is 30. This is across from the 1, which goes with the 30-degree angle, so this is 30. Reminder, this problem is in radians. 30 degrees, how many radians?
6.
Close? 5 or 6, yes. Good. 5 or 6. So now we know we're in sixths. So this is 6 pi. This distance here is pi over 6. So what's theta? Yeah?
5, 6.
Uh-huh. 5, 6 pi, 5 pi over 6. This is 1 pi over 6. Then we just subtract 1. We get 5 pi over 6. That is the value of our theta. Questions so far? Okay, let's do another one. This one we're going to kick it up a notch. Find theta. We'll do in radians again. And we are given sine of theta is -1. Cosine of theta is 0. So let's start with the sine. Let's rewrite this as a fraction. Sine of theta equals, we'll take care of the negative in just a moment, 1 over 1, which we know is O over H. One of these numbers will take the negative, and it's important we identify the correct one because that changes how we draw this. Which one must have the negative on it, the O or the H? The O. Reminder, H is never negative. So this is O is -1, H is +1. So we're going to start with that. And then side note, we know that sine is negative. Cosine, we're going to do the same thing. Cosine of theta, 0, that's one's easier. That's just 0 over 1. So we have A over H. So that means A is 0. If one of these numbers, A or O, is a 0, that should be suspicious to you. Does anyone know what that means about our angle, where it's located? Because we can't draw a triangle if it has a side length of 0. That's your hint. It's a quadrantal, yes. And it's on the vertical. So if A is 0, this means we have no horizontal side. Where am I going to graph my angle at? Going down, yes. Reminder, our O is -1. This is the vertical side going down. We have our angle of rotation. If it's easier, we could start in degrees and convert. That is an option. So this is 270 degrees, but we want radians. So that's going to make this a tad tougher. So let's put this in radians. We have 0/2 pi. And then we just have 1 pi on the side. Let's work with the alpha. Alpha is x-axis to our angle. Now alpha here, that would be 90 degrees, but we need to put it in radians. 90 degrees, what's that in radians? 1/2 pi, good. So we could use that tidbit of information instead of converting, which is still an option. You can convert degrees to radians, you know how to do that. But if you want to go a slightly quicker route, we'll use this information instead. So we have pi plus the 1/2 pi to get to this. So we have theta equals pi plus 1/2 pi. And then if we get common denominator, that's actually 2/2 pi. So that's 3 pi over 2. So theta equals 3 pi over 2. So on these problems, it's okay if you use degrees as the stepping stone to get into radians. Just make sure your final answer is in radians. Questions on this one? Okay, we'll do one more, and we're going to go further with it. Find theta, alpha, and the 6 trig functions. And we'll keep it light in degrees. This time we are given cotangent theta equals negative square root 3, and secant theta equals 2 rad 3 over 3. We primarily work with sine, cosine, and tangent. So anytime they give you the one of the three reciprocals, we're just going to put it back in terms of the original three. So cotangent theta, let's rewrite this in terms of tangent theta, which is going to be 1 over rad 3. Now the negative, little bit curious here, so I'm going to put it in front. We'll reevaluate whether it's the O or the A that gets the negative, because it could be either of them. But right now we know we have O and A. And this is one of the only times you will not want to rationalize the denominator, because these are the raw numbers of the sides. If you rationalize the denominator, you're going to give yourself numbers that don't fit one of the two triangle types, so leave it. We also know that tangent is negative. That's the other important piece of information. Secant, we're going to do the same thing here. Let's rewrite it. Secant is reciprocal of cosine. So this is cosine of theta equals 3 over 2 rad 3. Let's write out the two triangle types, 45, 45, 90, and 30, 60, 90. 45, 45, 90, 1, 1, rad 2, 30, 60, 90, 1, rad 3, 2. You can tell from the tangent information alone that this is going to be the 30, 60, 90 case. But if you go off of the cosine number, this does not fit either of these triangles. So it'd be more helpful if we could fix that. So let's rationalize that denominator to get rid of it and see if that will fix the problem. So I'm going to multiply by rad 3 over rad 3. That's going to give me 3 rad 3 over, this becomes 2 times 3, so 3 rad 3 over 6. Still doesn't match one of these yet. Notice we can now reduce this to just rad 3 over 2. That will be helpful information. That gives us A over H. And notice here the A is positive. So now we know A is positive rad 3, O is negative 1. And the other piece of information, cosine is positive. And we know that this is a 30, 60, 90 triangle. So I'm going to gather my information kind of in a little space over here, just to kind of organize it, because I did a lot there. We now know H, O, and A. H is 2. O, we now know O has a negative. It's negative 1, because the A down here was a positive rad 3. And then let's figure out which quadrant we're in. We know that tangent's negative and cosine is positive. That happens in one quadrant. Which quadrant is that? Good. Quadrant 4. Now, I know I jumped through quite a bit of hoops to get to that. This information over here, I technically could have figured out the problem without doing all this work, but I did make the work a little easier on myself, in my opinion, just discovering everything out the gate. So that's just me taking it a little bit further. All right, let's graph. And if you remember the directions, we're finding all 6 trig functions, so I'm going to go ahead and set up those blanks so I know how much space I'm working with here. So we have to find theta and alpha, but we also have to do all the trig stuff. sine of theta, cosine of theta, tangent of theta, and the reciprocals, cosecant theta, secant theta, and cotangent theta. And now we graph. We know we're in the fourth quadrant. Angle of rotation. We still need to figure out theta, so I'm going to leave that like that. Theta equals to be determined. Alpha, x-axis to our angle. Figure that out in a moment as well. The triangle, we already have everything that we need for that. H is 2. We're going to do HOA first. H is 2. O is -1. And A is positive square root 3. And then finally, filling in the angles. Of course, this is the 90. We know this is a 30, 60, 90 triangle. 30 is always across from the 1, so the 30 is here. So that means our alpha is 30 degrees. Making this up here the 60. I'm going to go ahead and fill in alpha before I forget to. So alpha is 30 degrees. And clearly we've made it all the way around into the fourth quadrant, so we're considering this the 360-degree angle. So the whole thing's 360. We know this is 30. What's theta? 330. Just do that subtraction, and you will get 330 for theta. Now the trig functions. Without doing any work, I can already figure out 2 of these answers very easily. Does someone know why? They were given. I'm not kidding you. I have had students miss this on the test, where they literally give you 2 of the functions and then they get those wrong in the blanks. Don't be that person. If you want to fill these out immediately when you get this problem, go ahead. But yeah, they already gave these to us, so those are free points there. Go ahead and fill them in. Cotangent is negative rad 3. And secant is 2 rad 3 over 3. Now the reciprocals, cosine and tangent, you could either just flip and get your answer, or you could do it the natural way. Either way works. I'm going to flip the cotangent. That's going to give me -1 over rad 3, which I will now have to simplify, times rad 3 over rad 3. That gives me negative rad 3 over 3. Now, I know that if I flip this, I'm going to create more work for myself. So I'm just going to go with the original numbers in the triangle, save myself a little bit of work. But you can flip this. You'll still have to rationalize the denominator. Cosine A over H, that's rad 3 over 2. And sine O over H, that's -1/2. Cosecant would be -2. Last thing, quick check. We're in quadrant 4. Which function is positive? Cosine. So make sure your cosines are positive and the other 4 are negative, and that does apply here.